Hello, this is Kevin Strutters going to explain how I do flowcytometry analysis in MATLAB. And so we begin by finding our data. Have this in a folder, preferably somewhere that's of utility. You may want to, when exporting from the Curie C6, go for the option of exporting to third-party software. You're going to get a lot of FCS files that look like this. The next task you're going to need to do is to go online. You're going to go to Purdue Cytospec. You're going to Google that. First link is going to be this website where you can download a program from one of Purdue's engineers, and they have designed a program that enables you to look and open those FCS files. From there, open up the program. Very old school, looks like this. I'm currently using a Windows PC. I've tested this on Windows 10 and 11. It works great for those. Let's go ahead and open up our files. So I've got a Flowcytometry folder here. Let's go to 2024 and locate your FCS files. I'm going to pull in these 9 files. We now have them open here on the left. Let's open them up. You can do this one at a time if you want. I'm just going to open them all at the same time. And now let's go to File, Save as Text. Save as text, save as, not as a scaled, just save as is. It's going to open up this file. We'll save it in the same folder, but you can save it kind of wherever you want. File, save as text, and we're going to repeat that process. Alright, you now have some text files. You can bring those in, take a look at them. You're going to see that they have a bunch of columns. And these have numbers that have not been cropped in any particular fashion, which is fabulous. Okay, this is where we now have a MATLAB file. My current workflow is version number 10. If you don't have that, email me or look on Google Drive. You'll find it there. This first section, I'll make this go down. So we've got some standard formatting here. This is for the cell culture facility. This is for the Bidney facility. At the moment, this is all cell culture data. Of course, this is going to change based on what outputs come in the FCS file. If you're looking at the Curie C6 on the 3rd floor of Brown, these haven't changed, and they don't change unless someone goes in and changes the filter keys. So keep an eye on that, but they haven't changed since the instrument was installed. We're just going to run that first section. Going to bring in some stuff. If you don't like beeps, then turn off your sound. Let's locate our file. This is where our text files are, and then it's going to automatically bring in anything that is a text file. Great. At the bottom here, this output is going to tell you which files it's brought in and which variable numbers in the data cell array is which data. And so the first one is going to be our T cells with no label that are day 29. The second one is going to be our T cells day 58 with no label. So on and so forth. That's section 1. If you ever forget what your data is, you can always go to section here. What data is what, and you'll get that output there. I don't think you have to run this twice, because I think I've already got that working up. So let's go into our gating section. Excellent, we immediately come to a program that we don't have, probably because I haven't set my paths in this most recent edition of my install. And so there are a number of dependencies. They're all, again, on Google Drive. Let's go to Documents, MATLAB, Functions, and we can just grab all of those. And let's give that another go. And dscatter is on there. Image expected. Fabulous. Okay, awesome. So it appears that dip image was imported, and so we get a draw polygon in a miscellaneous photo that I probably shouldn't have put on the path in one of Shaw's old folders. And so with that bit of correction, let's go back here. Awesome. And so now you're going to get a figure window. You're going to want to then gate the cells that you're looking for. It's now going to open subsequent images. And so you've got 8 files. You're going to have to gate all of your files. You'll want to, if you haven't already done this somewhere, run your cells with a live dead indicator, so you have a fluorescent readout for cells that are alive. I've already done this for all of these samples. Okay, here's some basic plotting limits. Fluorescent channel 1, 2, 3, and 4. 1 is your GFP, 2 is 488 and a 560 filter, 3 is going to be a 640, it's going to be a 488 and I believe 600 filter, and then finally you're going to be a 640, 640. I generally keep bins and smoothing factor the same. They work pretty good. If you happen to have some bead data, so let's see here, we've got 3 different kinds of beads. So we've got some AGFP beads. Let's take a look at those. Here we're going to go in and change this number to the number corresponding to our beads. So instead of 15, our GFP beads here are at 5. It's going to open up the file. It's also going to ask you a question: how many bead populations do you have? For the GFP, we have 6. That file, or sorry, that image that you opened up, let's go ahead and go and select in between the 6 populations. It's going to then fit all those populations with a Gaussian and record that data. It's then going to give you a standard curve. That standard curve has the previous unit of GFP, so the mean ensemble soluble fluorescence, the MESF values for the beads inputted. If you've got a new sample of beads, make sure to confirm that the values for the mean ensemble soluble fluorescence is appropriate. You'll find that right here. We've got the Takora Bio USA lot number indicated there, and those are the 6 values. All these different sections are going to plot exactly what the section says. We can get histograms, we can get 2D plots, and so if we take, if you want to get more sophisticated, there's some examples at the bottom of this script that go into a little bit of detail there, but otherwise that is how it's done. If you have questions, let me know. Otherwise, have a great day.